Welcome to the Deep Dive. Today we're really focusing in on Tesla's Robotaxi plans.
Yeah, there's been a lot of talk.
Definitely. We've looked at recent comments from Elon Musk, from Ashok Kilaswamy, their AI lead, plus some expert takes. And, well, we're here to try and make sense of it for you.
The big piece is this whole localization idea, right? What's that actually about?
Exactly. What do they mean by localization? And what does it signal about, the actual rollout of these self-driving taxis? So our mission today for you listening is simple. Get a clear picture of the strategy, what localization means here, the likely phases, and hopefully not get too bogged down in the jargon.
Sounds good. And yeah, it's a really interesting puzzle. We're lucky to have Phil's insights again. Founding Rivian tech team, ex-Apple engineering manager. His perspective on FSD has always been super helpful.
Absolutely essential. So yeah, let's dive right into localization. We've actually got that short clip of Elon and Ashok. Let's just hear what they said. Okay, localized parameter set. That's the phrase, right?
Yeah.
It causes a bit of, head scratching.
Yeah, you see people wondering if they're ditching the general AI or if they suddenly need to map every city block by block.
Right. So what's the real interpretation here? What's your take?
What seems much more likely, based on what they've said and just general AI trends, is this idea of localized experting.
Okay, expert.
Yeah. So think of it like this. Tesla's building one big general-purpose self-driving brain. That's the core.
Right.
But within that brain, they're creating specialized local experts, little modules the main AI can use when it hits specific situations.
Oh, okay. So it's not throwing out the main system. It's more like adding specialized tools to the toolbox.
Precisely. Elon's analogy, the California driver in a Manhattan blizzard,
Yeah.
it's spot on. The basic skill driving is there, but specific knowledge for, treacherous snow and ice.
Yeah.
That makes you better in that exact situation.
So the AI works the same way. It has a general driving down, but it can pull in this extra blizzard knowledge when needed.
Exactly. It leverages these specialists. And Ashok's point about China is key here, too.
Right. They got it working well there with minimal local data.
It really shows the strength of their main AI approach. They adapted to a totally different driving culture, different road markings, everything, without needing, years of local mapping or a whole new rule book.
Which contrasts with maybe some other approaches using HD maps.
It does. It highlights the flexibility of a learned AI-first system versus one heavily reliant on pre-built maps or explicit rules.
So how do these local experts, these specialized bits, actually fit into the bigger AI?
Well, the term that fits best is probably a mixture of experts architecture.
Mixture of experts, okay.
Yeah, it's a concept used in other advanced AIs. You have one main model, but different parts, different parameters within it are specialized for certain tasks. It all works together, but it's efficient.
Efficient how?
It means you don't have to run the entire massive model at full tilt for every single decision. You activate the relevant expert parts. It saves on compute.
Gotcha. Okay, so a mixture of experts using specialized modules. Let's maybe take one step back over the basic tech. Photons in, controls out. We hear that a lot. What does it actually mean for the car?
Right. So photons in is basically all the sensor data going into the neural network.
Primarily the cameras.
Primarily the cameras, yeah. 8 of them, seeing the world. But it's also pulling in data from the IMU, the inertial measurement unit, knows how the car's moving. GPS, obviously. Vehicle state, like speed, steering wheel angle, even audio, listening for sirens. And crucially, this context data.
Okay, context data. That sounds like where the localization part might really plug in.
Absolutely. Context data is stuff like, is it raining? Is there snow on the ground? What's the ambient light like? Nighttime, fog. This gives the AI vital information about the current conditions it's dealing with.
Makes sense.
So all that input goes in, and the controlled out is what the neural network decides to do. Steering commands, accelerator, brake, turn signals, the actual driving actions.
Okay. And this whole process relies on the AI model itself. Can you demystify the model a bit? We hear parameters, training. What is the model?
Think of it like a huge, intricate web, layers upon layers of interconnected points, or neurons. The connections between these neurons have values, weights, and biases. These numbers, millions or billions of them, are the parameters.
So when they say billions of parameters, it's just a lot of these connection values.
A lot of them. And the specific values are learned during this massive training process back at Tesla's data centers, using tons and tons of driving data.
And the software updates push this trained model to the cars.
Exactly. The update is the new model, the structure, plus all those learned numbers. Then, in your car, the model runs in inference mode. It's read-only, It takes the live sensor data, uses the weights and biases it learned, and calculates the driving outputs. It's not learning as you drive, it's applying its learning.
Okay, that clarifies the core process. So
Right.
back to this mixture of experts. Knowing how the model works, how does that specific architecture function within FSD?
Right. Well, you can imagine the evolution. Maybe early systems tried to do everything, see the world, perception, and decide what to do planning in one giant, dense model.
Uh-huh.
But it's more efficient and probably more effective to separate those. And the mixture of experts likely takes that planning stage and breaks it down even more.
So not just one planning module, but several specialized ones.
That's the idea. One globally deployed model, yes, but with the ability to call on these focused submodules, these experts, depending on the situation.
Like what kind of experts?
You can imagine an intersection expert, a highway merging expert, maybe a snowy conditions expert, a dense urban traffic expert, parking lot expert.
Makes sense. Each of those is a pretty distinct driving challenge.
Exactly. Different skills, different priorities.
What about something really specific like the pickup rules at Austin Airport? Is there an Austin Airport expert?
Probably not like that. Those super specific geofenced rules, like exactly where to stop for ride hailing, are more likely handled by the navigation system and that context data layer. The car knows I am inside the airport geofence and accesses specific rules for that zone.
Ah, okay. So context and navigation handle the hyper-local rules, while the experts handle broader driving scenarios.
That seems more plausible, yeah. Though maybe a general airport driving expert could exist for navigating the complex layouts, but the precise drop-off point is likely nav data.
Okay. So how does the information flow? The car's driving along. What happens inside this mixture of experts system?
Okay, so first, the perception layer takes all the sensor data and builds that object map its understanding of the world around it. Cars, pedestrians, lanes, signs, everything.
Got it. The world model.
Right. That map, plus the IMU data, the context data like weather, all gets fed into the planning layer. And within planning, there's this crucial routing or gating layer.
Routing or gating.
Yeah, its job is to look at the current situation derived from perception and context and decide, okay, which of my experts are relevant right now? And importantly, how much weight should I give to each expert's opinion?
So it's like an internal dispatcher deciding which specialist gets the job.
Pretty much. Say you're approaching a complex intersection, and the context says it's raining heavily. The routing layer might activate, say, the intersection expert and the wet weather expert. It then blends their outputs, perhaps prioritizing the intersection logic for right-of-way, but factoring in the wet weather expert's adjustments for longer braking distances.
And you mentioned efficiency before. This selective activation helps with that.
Massively. Instead of running the whole gigantic model, you're primarily using the compute power for the parameters of the activated experts in that specific moment. It's much faster, like calling only the consultants you need for this specific problem, not the whole firm.
Right. And Tesla's own chips, the hardware in the car, are designed for this. HW3, HW4, the upcoming HW5, AI5.
Exactly. They're built for parallel processing. They can handle inputs and calculations from multiple experts simultaneously, not just one after the other. That parallel capability is key to making this mixture of experts approach work efficiently in real time.
Okay, this tech explanation is really helpful. Let's shift to the rollout then. How do they actually plan to get robotaxis on the road? It doesn't sound like flipping a switch overnight.
No, definitely not. It's going to be phased. This idea of Project Rodeo seems to be the first step.
Project Rodeo, what is that exactly?
It looks like the current pre-trial phase. They've got, around 300 test operators in Austin right now?
Yeah, something like that.
It's very likely they're using a newer model, maybe this version 14 we've heard whispers about, probably unsupervised, more parameters, maybe optimized for the newer HW4 or even future HW5 hardware.
And these operators, what are they doing? Just driving around?
Several roles, probably. Some are likely safety drivers, supervising the system, ready to take over. Others might be employee riders, just experiencing the ride, giving feedback. And crucially, they're probably also training and testing the remote assistance systems.
Ah, the remote oversight part.
Right. And this whole phase is about validation. Rigorous testing. Think code coverage from software development. Meaning they systematically try to drive every road, every intersection type, make every kind of turn in Austin. They need to ensure this new model has no regressions. It doesn't suddenly fail where older versions worked.
So building confidence and a safety case. especially with everyone watching.
Exactly. Safety is paramount. They need data to show it's been tested thoroughly under all sorts of conditions before they let the public in. If something did happen later, they need to show they tested that specific scenario extensively beforehand.
Okay, so that's Rodeo, the pre-trial. What's phase 2, the actual trial?
That's likely the next step, moving to maybe 10, 20 vehicles initially, but with real paying customers. Still probably just in Austin to start.
Okay, and could they scale that up quickly if it goes well?
Potentially, yeah. Adding more vehicles might be relatively fast if the initial small fleet performs well. But we should also expect pretty granular geofencing at first.
Meaning the service won't cover all of Austin right away?
Probably not. If there are specific intersections or zones they're still a bit uncertain about, or where performance isn't perfect yet, they'll likely just exclude those areas from the service map initially.
A cautious start.
Very cautious. And still tons of data recording. Every input, every slight disengagement, every intervention, even if minor, will be logged and analyzed to refine the system.
Okay, and then beyond the Austin trial, phase 3.
That's the larger scaling. Moving towards potentially thousands of vehicles, this is likely where the purpose-built cybercab comes into play.
The one without steering wheel or pedals.
And expansion beyond Austin, where, well, maybe other Texas cities like Dallas, major California spots. Phoenix is often mentioned, partly because Waymo is already there.
Right. And Elon's timeline mentions customer cars joining the network maybe late next year.
That's the goal they've stated, yeah. Second half of next year for customer cars potentially earning revenue. He also talked about Robotaxi revenue starting to move the needle financially around then and seeing multiple cities this year.
Ambitious targets.
Definitely forward-looking statements, but it shows the ambition.
So for you listening, the key thing is expect a gradual rollout, starting small, likely with limited zones in Austin, and expanding carefully over time as they gain confidence in data.
And the logistics, like charging and cleaning, probably leveraging existing superchargers and service centers to begin with. It's a step-by-step process.
Okay, so let's try and wrap this up for you. The big takeaway on localization, it's not about separate city AIs. It's about making one smart general AI even smarter by giving it specialized expert modules for tricky situations.
Right. Enhancing the core system, not replacing it city by city.
And the rollout strategy seems very methodical. This Rodeo testing phase in Austin first, then a limited customer trial, also likely geofenced, before any bigger expansion. Safety and data gathering look like the priorities.
And the underlying tech relies on that sophisticated mixture of experts idea, using parallel processing on their custom chips to make decisions efficiently.
Okay, so here's maybe a final thought for you to chew on.
Yeah.
This whole mixture of experts thing in AI, how else could that apply? Not just driving, but maybe other complex problems. Or even how humans learn skills. A general ability boosted by specialized modules. What are the implications?
That's a great question. The idea of combining broad competence with deep specialization, it's powerful. Definitely something worth pondering.
So if you're interested, maybe do some searching on mixture of experts in AI. And of course, keep watching Tesla's FSD and Robotaxi progress.
It's certainly going to be fascinating to see how it unfolds.
Absolutely. Hopefully this deep dive has given you a clearer framework for understanding what's happening and what to look for next. Thanks again for bringing your expertise.
My pleasure. Always interesting stuff.